Hello and welcome to everyone. In previous lecture, I will discuss about the moment of force or torque, which is represented as force into perpendicular distance d, and SI unit of torque or moment of force is Newton meter. Okay, today I will discuss about the direction of moment of force or torque. To understand the direction of moment of force, here we have two cases. In one case, the bar AB, the applied force is acting at point A in upward direction, which causes the rotation in this direction, that is anti-clockwise, and in case 2, the applied force F is acting at point B in downward direction, which try to rotate the bar AB in clockwise direction. Thus, these two, the direction of rotation of bar, represent the direction of moment of force or torque. If force is acting in upward direction, then the direction of moment of force will be anticlockwise, which is conventionally considered as positive. And if the force is acting in downward direction, which causes rotation of bar in clockwise direction, which is conventionally taken as negative. Now, condition for maximum turning effect, that is for maximum moment of force or torque. Moment of force can be expressed as force into perpendicular distance. Then for maximum moment of force can be obtained by either F equal to 0 or D equal to 0. Then the moment of force will be 0. In this case, if force is applied at the end B, the bending for maximum bending moment, either F will be maximum, or T will be maximum. Then the net moment of force or torque will be maximum. If force is constant, then the value of moment of force can be increasing with increase the perpendicular distance d from the axis of rotation. Here, if force is applied at various points represented as d1, d2 and d3, here d3 is maximum, then d2 and minimum is d1. Therefore, in this case, the maximum moment of force maximum moment of force will be equal to force into d3. Then the moment of force will be maximum when the perpendicular distance between the line of application of force and axis or point of rotation is maximum. The practical example of moment of force is opening and closing of doors, in which the one end of the door is hinged with the wall and the other end is free. At the free end, the handle is located, due to which can easily open and close the door by applying minimum force. If the placing of handle other than the outer edge, then it is difficult to open the door or more force is required to open the door. Another example is to open or tight a nut with the help of a wrench. The effort or force is applied at the free end, which easily help to open or tight the nut. And another example is the long arm of a screw jack can lift a heavy vehicle easily. The long arm is responsible for the maximum turning effect or maximum moment of force, due to which the heavy vehicle can easily lift by help of screw jack. Second condition is for zero moment of force or torque. As we know that moment of force will be equal to force into perpendicular distance d. For zero moment of force, either F will be equal to 0 or D will be equal to 0, then the moment of force will be 0. And D will be 0 when force is applied at the hinged end or pivoted end of the body, then the moment of force will be 0. that is, if line of action of force passes through the pivoted end or hinged end or the axis of rotation, then d will be equal to 0 and the moment of force will also be equal to 0. Now we have to discuss about a numerical problem which is asked in 2015. To open a nut, list force required on a wrench is 2 Newton. Wrench length is 20 centimeter. Then find the required moment of force. Here we have a wrench AB through which we have tried to open a nut. The least required force is 2 Newton and the distance of applied force and the range is 20 centimeter. Then we have to find the required moment of force. As of definition, we know that moment of force will be equal to force into perpendicular distance. Here force is 2 Newton and distance is 20 centimeter. First of all, we will convert centimeter into meter because the unit of force is in SI unit. Then we can write here and after solving we get that value of moment of force will be 0.4 Newton meter. Then the required moment of force will be 0.4 Newton meter. Answer. Hope you like the video. In next lecture we will discuss about the different examples related to this topic. Thank you.